Alright, looking at an application of exponents comes in the form of scientific notation. Now, if scientific notation is brand new to you today, I really hope that you pay attention, but I'm really hoping that this is a review from a science class and that we've used it because it comes up all the time in science. Heck, it's called scientific notation. So, when we're going from standard form, which like a number like this is in standard form, this is in standard form. When we're going from standard form to scientific notation, there's four things we need to do. First, we need to move the decimal to the right of the first non-zero digit from left to right. So as you are looking at the number from left to right, put the decimal place to the right, so just after, you could say just after the first non-zero digit. After that, you're going to count the number of places the decimal was moved. Count the number of places the decimal was moved. If it was moved to the left, that number is negative. Sorry, that number is positive. If it was moved to the right, this is where the negative comes in. That number, again, there's an extra hump in there, that number is negative. That number is negative. Then we're going to remove unnecessary zeros. So it's going to go just like this. We see we have this number 201 billion. That's a lot of zeros, and we can write it in a more condensed way. So the decimal place would live right here. We're going to move it to the right of the first non-zero digit from left to right. So we're going to put it right here after the 2. We're going to put it right there after the 2. Now we're going to need to count how many digits we moved it. We moved it 1, 2, 3, 4, 5, 6, 7, 8 places. We moved it 8 places. And we moved to the left, so that 8 is going to be positive when we rewrite this as 2.01 times 10 to the 8. 2.01 times 10 to the 8. Now, here we have what looks like 0.000051. The decimal place is already here. We're going to move it to the right of the first non-zero digit from left to right, so right here after this 5.1, this 5, making it 5.1, and we're going to count 1, 2, 3, 4, 5. We went to the right, so it's negative, so this is now 5.1 times 10 to the negative 5. 5.1 times 10 to the negative 5, putting it into scientific notation from standard. Now going from scientific notation to standard, we have 3 steps. First, we need to note if the exponent is positive or negative. After that, if it's positive, we're going to move the decimal places. We're going to move the decimal that many places right. If it's negative, we're going to move the decimal that many places to the left. Then we are going to insert zeros as they belong. So for example, if we see 6.32 times 10 to the 9th, I'm going to rewrite this 6.32 here times 10 to the 9th. We note that that 9th is positive, so we're going to move the decimal place where it is 9 places to the right. So we go 1, 2, 3, 4, 5, 6, 7, 8, 9. We re-put our decimal place and we fill in with zeros. Hopefully you've seen this kind of bumpy method before because that allows us to keep track of how many zeros we need to put in. Now if we have 4 times 10 to the negative 7, I'm going to rewrite 4 and the decimal place would be here. Since it's negative, we're going to go 7 places to the left. So we're going to go 1, 2, 3, 4, 5, 6, 7. We put our decimal place right there and we insert the zeros that we need. We can put a courtesy 1 before the decimal if we want, and now we're back in standard notation. Now, if we're going to multiply or divide using scientific notation, we kind of need to do this in 2 steps. First, we're going to multiply or divide the bases, and by the bases probably isn't the right term. We're going to use this first term here. We're going to multiply this first term here. So our number that's always between 1 and 10. It's always between 1 and 10. It's never anything more. This first number here is always between, if we called it A, is between 1 and 10. So multiply the bases, then the powers, or then the tens to the whatever. Then we're going to adjust our scientific notation. So for example, if we have here 6.5 times 10 to the 12th times 8.7 times 10 to the negative 15, first thing we're going to do is 6.5 times 8.7, which comes out as 56.55, 56.55 times 10 to the, when we multiply 10 to the 12 times 10 to the negative 15, that's like 12 plus negative 15, which means times 10 to the negative 3. Except we need to adjust our standard notation to make sure we're in scientific notation so that that 56 is not a 56, but is in between 1 and 5. So we're going to move this over 1, and we moved it to the left, so that means we need to make this number more in the positive direction. So this is going to be 5.655 times 10 to the now negative 2. Or think we made this number smaller, so this number has to be made bigger from negative 3 to negative 2. Now if we look over here and we have 1.305 times 10 to the negative 3 divided by 1.45 times 10 to the negative 4, if I do let's clear that, 1.305 divided by 1.45, I have 0.9 times 10 to the third divided by 10 to the negative fourth. We remember that's 10 to the third minus negative 4, which comes 10 to the 7. But this isn't in scientific notation yet because this isn't between 1 and 10. So you have to move the decimal place 1 to the right to get 9, which means that we have to move this in a negative direction, so 10 to the 6th. Also think we made this bigger, 0.9 to 9, we made it bigger. So this 10 to the 7 is going to become smaller by going 10 to the 6th. This is tricky, and I advise you, if you're confused on how to multiply and divide, read the section in the textbook. Maybe that will help. Looking at our practice problems on page 983, 21 through 51 multiples of 3. Starting with 21, we need to put 58,600,000 in scientific notation. Sorry, you can't see. 58,600,000 into scientific notation. So remember, we're going to take our decimal and we're going to move it we're going to put it to the right of the first digit going from left to right. So we now have 5.86, and we're going to count our decimal places 1, 2, 3, 4, 5, 6, 7. And since we moved to the left, since we moved our decimal to the left, we're going to have a positive times 10 to the 7th, alright? Review this if you need to. Hopefully scientific notation isn't brand new and we've seen it before. But rewatch the video, read the book, look up other videos, do what you need to do to make sure you understand.